Hello my dear students, welcome to day 29 of our ongoing series, which is 16 out of 16 KCET mathematics in 100 days. Okay, so this is me Ankit Srivastava welcoming you to our YouTube channel Diksha Karnataka. I hope all of you are doing very good. Yes, today we are talking about a very complex topic. 70% of people find this topic difficult because of the longer version of the formulas. I'll try my best to break this formula into simpler terms so that we can recall and we can revise this, and whenever we are solving a question, we can recall these formulas in the simplest way possible. Okay, so today's topic of discussion is what? Particular functions and partial fractions. So I have taken in total, if I remember, 9 questions. Okay, I think 2 questions I've taken on the partial fractions, and particular functions I've taken rest of the questions. So we'll see the application of we'll see the application of partial fraction in the particular functions. So for those formulas, we'll see how can we apply the particle functions, and we'll solve these concepts using application of both these categories. One more thing, this is not enough, this is not end of it. We'll come back and solve more and more questions of it. So what I'm trying right now is, since some of the students are not having any problem with any of the topics, okay, only they want revision or they want to solve some questions and learn the concepts quickly and then go to the question solving. So for that reason only I'm coming here with this topic. Otherwise I could have taken more questions on the substitution method. Okay, so what I'm going to do, allow me to complete all the topics first, all the concepts first, and take questions on them at the same time, okay, at the way we are doing. Later onwards, as per your request, as you have asked me to take more questions in the calculus, so what I'm going to do, I'm going to keep additional sessions for just questions only. So I'll mention that today's session is about partial fractions, and we'll solve questions on only partial fractions. Okay, indefinite integral, we'll solve a variety of indefinite integral. So I'm going to keep the session wise questions, so that will come later at the end of the when all the concepts of this chapter is complete. Okay, I hope that is all right. So let me start with the session. So what is it? I hope you're ready. Okay, take your pen and paper out and let's start. So again we have how many bacha? We have total of 4 here and 3 there, 7 different formulas. Okay, out of those 7, 2 are very simple, and in other 5 we'll try to create a link so that it's easier to remember. Okay, so obviously in the other 2, apart from these 2, other 5 formulas uses what? Uses logarithms after differentiation, after integration. So let's look at the first one. The first formula is, whenever you have, so I can create a category over here. Category means, sir, it is in the denominator. The term which we are integrating is in the denominator. Also, there is no root. That's why I kept it over here. If you see on this side, everywhere you can find the root and root. See, root is there, root is there, root is there. Whereas in this case, there is no root over here. And the last one, it is in the numerator side. Okay, please understand. So I'm trying to create a like a category so that in this particular function, so that it is easier for us to solve and remember the questions, the formulas. Sorry, forgive me. Chaliye. So look at the first one. Look at the first one. Again, there is no root involved and square terms are there. That is very mandatory. X square minus a square. So whenever you have this type of question, okay, because this will not be like this, no, because usually what will happen, you will have, instead of x, you will have some variable here. It can be t minus 5 by 7 the whole square, okay, and it can be what, 3 by 9 the whole square. Okay, so it will not be simply like x square minus a square. Okay, so instead of x, you will have a variable term like this and a constant term like this. So whenever you have this type of situation, okay, we call this to be x and we call this to be a. So this will transform into x square minus a square category. If you are asked to integrate this with respect to what? The variable x. In this case it is t, so we'll take it as t only. No confusion. Okay, variable is t na, so we'll keep it as t. If you are asked to do that, what are you going to do? Simply take 1 by 2a. Okay, I told you log will come in apart from the 2 formulas. Log will come, modulus will be there. Why, sir? Because log cannot operate on a negative number, only what? Positive numbers it can operate on, not even 0. Okay, so what are you going to do? It will be a fraction. So if it is x square minus a square, if it is x square minus a square, you will write x minus a in the numerator and x plus a in the denominator. Understand this. If it is x square minus a square, you will write here as x minus a, x plus a. If it is ulta, if it is what, bacha? If it is a square minus x square, everything will remain same. It will be 1 by 2a. If it is a square minus a square, means first the constant square is first and then comes the variable square, means this variable bracket will come later and this constant bracket will come first. If that type of situation is given, 1 by 2a will remain as it is, log will also remain as it is, but instead of writing x minus a, we'll write a minus x, but where? In the denominator. I'll repeat this part. Instead of writing x minus a, here it was x square minus a square, we wrote here x minus a, okay. Instead of this, we'll write here a minus x, but not in numerator, we'll write in denominator, and this will become what? A plus x or x plus a, does not matter, right? Sum is not going to change. A plus x or x plus a, please check. So a plus x upon a minus x, okay. So can you see the pattern? If you have x square minus a square or a square minus x square, everything will remain same, 1 by 2a will remain same, log will remain same. Just in case of x minus a, you'll have x minus a here. In case of a minus x, you'll have what? A minus x in the denominator. This is how you can recall and try to remember these bigger formulas, okay. Now this is so very simple. Yes, why this is very simple, sir? If you remember this formula, integration of 1 plus x square dx, how much is this? How much this integration is? If you remember, this is simply tan inverse of x plus c, sir. Yes, sir, we know this. Differentiation of tan inverse of x is 1 upon 1 plus x square. So integration of 1 upon 1 plus x square is tan inverse of x. So not a problem there, sir. Same concept here, bacha. Check here. Instead of a constant 1, if I replace this in this formula, a as 1, check here. If I write this as 1, it will become 1 plus x square. It will become what? 1 upon 1. It will become what? Same thing. Tan inverse of x upon a will become x upon 1. So same formula. So this is the same formula actually. So whenever, if you have this category of a square plus x square, okay, simply write it as 1 by a tan inverse of x by a. We used to write only tan inverse of a because there was the constant a was simply 1, okay. But here if there is a constant, let's say 3 by 2 or bigger number, whatever it is, you write that 1 by a here, and same thing you'll do with x by a also. So I will again recall for all the particular functions when you have in the denominator without any root, okay, in this form. So if you have a minus sign, x square minus a square, a square minus x square, log will come after the integration, 1 by 2a is constant, and if it is x minus a you will write in the numerator. If it is a minus x you will write in the denominator. Yes or no? Yes. If it is plus sign, simply tan inverse form. This is very easy to remember, right? Tan inverse form is very easy to remember. From here you can relate from that. In a question, if that form is coming, simply remember tan inverse of a will apply with 1 by a and x by a. There is no 2a here, only 1 by a, okay. I have verified this with the help of 1 plus x square also. So let's move on. Let's see what is next. So next that we have is this where the roots are involved, the category of the particular function where the roots are involved, okay. So please check here. Before going to roots, I will deal with this part. Again, if you remember, integration of 1 upon 1 minus x square, what was this? If you remember this, simply sine inverse of x plus c. Sine inverse of x plus c, right? So if you have a constant a here, what are you going to write? Simply x by a. That's all. This is also very important and very easy also to remember. If you have in the root a square minus x square, which reminds us to the form of 1 minus x square, you write it as sine inverse of x by a, no coefficients. Sine inverse of x by a, here no coefficients, okay. Chaliye. Now these two categories, look at here, they are almost like a mirror image, okay. X square minus a square and a square plus x square. Sir, plus means tan inverse. No bacha, plus only if there is no root. Plus only there is no root. If there is a root, then again we will come back to log. I told you all particular functions have log except for that inverse trigonometric functions, which is 2 of them, okay. That is in our syllabus. In our syllabus we have only 7. So we are coming to what? A square plus x square. Now looking at this, please have a look. So if you look at this part, okay. So if you have a category like this, what are you going to do? Simply write log, okay, and then take what? X, and whatever is written over here, same thing you will write over here. That's it. If it is written like what? A square minus x square, or x square minus a square, sorry, a square minus x square will become sine inverse, no? Forgive me. If it is written like x square minus a square, please check. If it is written like x square minus a square, then what are you going to do? write this as it is, nothing will change, this will also be plus. Instead of this bracket writing at like this, you write it as x square minus a square plus c. Please check. Both of these formulas have same setup, only this part changes, and that you can relate from the thing that we are looking to do. Okay, so when will this log of x plus the term will come? If the integration is there for the denominator and root is existing for the differences or sum. Differences or sum. Okay, now the last category, the last one, when there is no root and also there is no denominator. If you have a square minus x square given in what? So you have a perfect squares of a constant and a variable term given in numerator. Okay, then what are you going to do? Simply write it as x by 2. Write it as x by 2, same thing repeat over here. Okay, see this, x by 2, same thing repeat over here, and next one plus a square by 2 sine inverse of x by a. Please check. Whatever is there, repeat this with x by 2 plus you write a square by 2 and sine inverse of x by a. I have taken question on this category, okay, to explain you, and I have taken question on other categories also. I think I have taken question on either of these one. Okay, so try to take question on 4-5 categories out of this 7 that we have. We have total of 7. Okay, I'm going to take it on 4-5 categories and solve it few questions today. Okay, Acha, one more thing. Please do not be worried if you are having difficulties at the end of this session also. Do not worry. I will come up with more sessions and solve more questions on particular functions. Okay, so please allow me to complete entire syllabus for the integration right now. Okay, with 8 to 10 problems that I'm taking every time. So let's solve these questions, understand the concepts. Right now, understand the concept. That's what all I'm asking from you. Okay, please be with me, understand all the concepts. By the end of this session, if integration, before I complete integration, I will make sure that I take 2-3 sessions and I'll solve only questions in those sessions. Okay, so do not worry about it. I understand your concerns. I've seen the comments. Okay, that's the calculus is there, integration is there. I felt when I was teaching, I think ITF also or something else I was doing in this KCET series, people were commenting that, sir, it is easy, that's why it is easy. Yes, correct, this is easy. Yes, I know that. Those things were easy, and they were saying integration is difficult. So I understand that you find integration difficult. So I will take up more and more session, and I'll make sure that I solve enough amount of questions so that your doubts are cleared. Okay, so do not worry about that. I'll be patient with you. You also be patient with me. Let me complete the portions. Then I'll come back to solving of more problems. Okay, moving on. Again, 2 special categories. Okay, whenever you have this quadratic term with or without root, okay, what are you going to do? Try to make it, see this is resembling to the formulas that we have. First one is denominator with some square terms. Okay, second one, denominator with square root of square terms. Yes or no? So right now, sir, but not directly resembling, sir, not direct resemblance, sir, no direct resemblance to the formulas. How are you going to solve it then? So what we're going to do, take this expression ax square plus bx plus c and convert it into what? Perfect squares. We'll convert into perfect squares. I'll show you how, don't worry, I'll show you. I've taken the questions, I'll show you. Once you convert into perfect square, what are you going to be ending up with? You'll have a perfect square like this, let's say x minus 5 by 4 the whole square. Okay, then you'll also have a constant term here, let's say 9 by 16. Now if you see here, whether there is a root or not, this resembles to the form x square plus a square. Put a root here also, x square plus a square in the root. Okay, so you will have these forms once you can convert these given quadratic expressions in the perfect square forms. Okay, this is the another form. So please check the steps. Make the coefficient x square as unity. Why unity, sir? Please check here, everywhere of x square, what is the coefficient? 1, 1, 1, here also 1, minus 1, 1, minus 1. So every place you have this coefficient as unity only, bacha. That's why you make all the coefficients unity so that you can use the respective formulas. Okay, then what we're going to do, express the resulting expression in perfect square. Okay, and when you do that, check that which one of the formula that we learned of the 7 is suiting our particular question, and we'll use that particular question, particular function to solve the integration. Is it okay? Chaliye. Okay, now what if we have this sort of form? Means there is a quadratic term with or without root, but we also have a linear term in the numerator, sir. Okay, we also have a linear term in the numerator. So if you remember the previous session, I said we will be using substitution not only in those particular questions which is used for substitution, everywhere we will use. So this is a question where we use substitution. We can use substitution also directly, but what I'm trying to do here, we'll see that. So if you see this, sometimes what happens, you see this, when you differentiate it in some questions, when you differentiate the denominator, you'll simply get the numerator. Okay, so this whole thing will become a dt or whatever the variable you've taken, you can substitute that and solve the question. Okay, again another form is what, just write the denominator, okay, with the differentiation, okay, and multiply that with a, means the differentiate the denominator, multiply that with a, add a variable b. What is a and b, sir? Any, just a variable b, a and b, we'll find the values of a and b. Just for now, what you're going to do, so let's say denominator, I'll call it as, let's say d, okay, so I'll differentiate this d, okay, with whatever the variable is involved, okay, add a b to it and multiply a to only this differentiation and equate it with the numerator px plus q. Okay, again if you differentiate, you'll have an x term, you might not also have x term, whatever it is, you compare that coefficients with p and q. P is the coefficient of x and q is the coefficient of q is just a constant term. If you compare it, what you're going to get? You're going to get the values of the variable a and b, and now what you're going to do, use this a and b to write the numerator in this form, okay, write the numerator in this form and then integrate it. Then integrate using what? Again, suitable formula of particular functions. Okay, we'll see. Right now it doesn't make sense to you, it's okay. When we solve the questions, it will certainly. Okay, chaliye. Now find the values of x square minus 1 dx. Okay, we have to integrate this. Simply what? We have to integrate this bacha. Okay, simply what? We have to integrate it. Means what is the result of this? That's what they are asking us. Let's see what we can do about it. So my integrand I looks like this. Please check. I can write like this as, so if I take x square common in the numerator, what I'm going to get, please check, x square 1 minus 1 upon x square divided by x square plus 1 plus 1 upon x square dx. Now you might have a question, sir, why did we take the x square common? Because bacha, perfect square we will use using what? X square only. We'd have an extra x square. I wanted to cancel that out. Check this out. Gone. Okay. Now please have a look. Now I am left with 1 minus 1 upon x square, and I also have x square. Okay. I have this 1 upon x square also. Means I have a square b square. What did I say? Whenever you have this form, a square plus bx plus c, what are you going to do? Make the perfect square. For the perfect square, I have a square, I have b square. How, sir? How, sir? A square, I also have b square. Correct? I have a square and b square. What is missing? 2ab. Let's try. Write it here. 2a and b. Yes or no? Yes. Okay. Now have a look. 1 second. Yes. Okay. All right. Now if you see over here, I have added what? What is this going to be? Simply cancel it. Simply 2, right? I have added an extra 2. So I have to do what? Subtract an extra 2. Correct? Now this is my additional 2. I have to take that out, and there is a 1 over here. So add this plus 1 also. And okay, this is my denominator. Please have a look. Please have a look. Okay. This is as it is. I have made some arrangement to have this form 2ab. Now please have a look. My I will look like this. I can write it over here also if you'd like. 1 minus 1 upon x square multiplied with dx with respect to integration with respect to the variable x. Okay. Now if you check here, I have what? X plus 1 by x the whole square. Yes. And minus 2 plus 1 will be what, bacha? Minus 1. Yes. Now if you check here, any formula coming in that way? 1 minus 1 upon x square is there, right? Okay. I don't have to write it again, same thing. Let's check here. I'm going to use substitution directly now. So if I take this as a variable t, can I do that? Please check. X plus 1 by x, if I take this as t, okay, differentiate it. Why differentiating, sir? Because if I'm changing this to t, I have to change dx to dt, and how can I get dt from dx from t? I have to differentiate t with respect to x, so I'll get what? Dt by dx equals to 1, x is 1, and for 1 by x what I'll have? Minus 1 upon x square. Differentiation, you know, x power minus 1 will come, you'll take the minus 1 over here, and again like this, okay. So basically x power minus 1 by 2 will be given, so x power minus 2 will be given by 1 upon x power 2, okay. Let me erase this, Chaliye. Now we will use this in the given expression. If you see here, this is present, right? So I can write dt as 1 minus 1 upon x square times what? Dx. So my numerator will become simply what? Dt. So I can write my integrand I as integral of dt upon, this is what bacha? T square minus 1. Okay, t square minus 1. I can write it as t square minus 1 square. Have a look. Integration of I. So integration I is given by dt upon t square minus 1 square. X square minus a square. What is the formula, bacha? Tell me. 1 upon 2a. What is a? 1. Okay. Then what? Log of x minus a is there. So x minus a will come in the numerator. So t minus 1 upon t plus 1. Okay. If it was 1 minus t, what are we going to do? We'll write in the denominator. Okay. Chaliye. So 1 by 2 log of, what was t? T was x plus 1 by x minus 1, x plus 1 by x plus 1. Please have a look. No problem. Okay. Please have a look. Yes. T was x plus 1 by x. Okay. Chaliye. So simplify this. 1 by 2 log of what? What is this? X square plus 1 minus x whole thing upon x, x square plus 1 plus x whole thing upon x. Cancel this and x, right? This x and x cancel. What is my answer? Final answer, I is equals to what? 1 by 2 log of x square minus x plus 1, x square plus x plus 1. This is my final integration. Please have a look. I'll show you from the beginning. Okay, I hope this is visible. Okay. Yes. Yes, sir. Okay. So you see, yes, there is a calculation. There is a bit of calculation, but we can do it. Okay. If you remember the formulas, how to remember, I've given you the hints to it. With practice also you can remember. If you solve more and more questions, and I will solve with you more and more questions. Look at this problem. Again, I can use some substitution. How, sir? I have something in the numerator. Okay, I can use substitution for that. We'll see how. Let's look at this. For right now, I can write this as my integrand I as integral of sec x tan x upon 9 minus 16 tan square x dx. Yes or no? Yes. Use the identity for tan square x. What are you going to get? Please check. Integration of sec x tan x upon 9 minus 16 sec square x minus 1 dx. Yes, the identity of tan square, 1 plus tan square is sec square. So 1 plus tan square is sec square. So tan square is, bring 1 on the other side. So will become tan square equals to sec square minus 1. Same thing we have written here. Okay, please check. Secant x tan x. Okay, expand this over here, you'll get what? 9 minus 16 sec square x plus 16 dx. Yes or no, bacha? Yes. Minus 16 minus 1 is plus 16. Okay. 16 plus 9 will be what, bacha? 25. So I'll get what? My integration I will look like this. Okay. Okay, I will be integrating, will be looking like this: secant x tan x upon 16 plus 9, 25 minus 16 secant square x dx. Yes, secant square x dx. Okay, this is simple, very very simple. Now have a look. Once this is simple, once this is simplified, if I take this as, check here, this is 5 square and this is 4 sec square. Yes or no? 5 square and 4 sec square means I have this form coming up, a square minus x square, but this numerator is giving me the trouble. If there was no numerator, I can write this as simply a square minus x square formula for log. Okay, but this numerator is the trouble here. So what I'm going to do? Substitution, sir. Sec x equals to t. Differentiate it, bacha. dt by dx equals to sec x tan x, sir. Okay, bring that over there. dt equals to what? Sec x tan x dx. Okay, yes or no? So sec x tan x dx will become what? dt. Will become what? dt. Yes. Now what is this? Simply 5 square minus 4t the whole square. How, sir? 4 sec square, right? So 4 times 2, 4 square is 16 and t square is just simply sec square. Okay. Now please check. This will be given by what? This will be given by what? Simply 1 by 2a. So 1 by 2 times of 5. Okay. 1 by 2a. Okay, one more thing. Please forgive me. A blunder I was about to do. The coefficient of t was always what? 1. So I have to take this 4 common. Okay. So if you don't mind, I will rewrite this step. One more step I have to write. I write it as 16 t square. 16 t square. Take 16 common now. If you do that, what are you going to get? Please check. You're going to get 1 by 16. Okay. dt. This will be what, bacha? Tell me. 25 by 16 minus t square. The integration. Yes or no? Okay. So if you look at this, I can write it as 1 by 16 outside. Okay. And this is integration of dt upon 5 by 4 the whole square minus t square. Yes or no? This is my integration I. Okay. Same thing is repeated over here. After substitution also, I is the same thing. This all of this is my integrand only. Okay. Please have a look. Okay. So my I is now, I'll rewrite this whole thing again. 1 by 16 integration of dt upon 5 by 4 the whole square minus t square. Which form is this? A square minus x square. A square minus x square. How will I write this? 1 by 16 will be outside. I have to write what? 1 by 2a. So 1 by 2 times of 5 by 4. Then what will come? Log will come. Over here, a minus x is there. So it will come in the denominator first, sir. 5 minus 4 minus t and 5 by 4 plus t this. Correct? 5 by 4 plus t, 5 by 4 minus t. Okay. So if you check here, 4 times 4 is 16. Now 4 times of this is going to be what? Doesn't look like this. So let me just rewrite this part again. This is 4. Okay. So 4 times 5 is 20 times 2 is 40. So 1 by 40 log of 5 plus 4t upon 4 divided by 5 minus 4t upon 4. Yes or no? 4 and 4 goes out. What I get? 1 by 40 log of 5 plus 4t means 5 plus 4 sec x. This is what? 5 minus 4 sec x. Please check. And plus c is always there. The constant c is there for the integration. This is my final answer. Please have a look. Okay. Please have a look. Sec x is my this substitution. So my answer is 1 by 40 log 5 plus 4 sec x upon 5 minus 4 sec x. Have a look from the beginning. I hope this is visible. Yes, this is visible. Moving on. Yes. Again over here. All right. Chaliye. Third problem. 1 upon 16 minus 9x square. This is very, very simple. Yes, very, very, very simple, sir. is simply given in that form. I take this, just have to take the 9 out because the coefficient has to be, the coefficient of x1 has to be unity. So I'll take the 9 out. Please check. My integration I will become integration of 1 upon, take 9 common, so 16 by 9 minus x square dx. Please check, please check. I have taken this 9 commons, 9 times 9 will be 16 again, and simply 9x square. So this is correct. Okay, please have a look over here now. Next step, I'll bring this 1 by 9 outside. Okay, now what does this become? Integration of what? 1 upon 4 by 3 the whole square minus x square. Same formula, a square minus x square. Okay, so I equals to what, bacha? 1 by 9 times 1 upon 2a. So 2 times of 4 by 3. Okay, log of what? Same thing, 4 by 3 minus x, sorry, plus x in the numerator, and 4 by 3 minus x, because it is a minus x square, right? A square minus x square. So this will come in denominator. Okay, please check. I get it as 3 3s are 9. Okay, 3 2 is 6 times 4 is 24. My answer for I is 1 by 24. 1 by 24. Okay, log of, I'm going to write directly, 4 plus 3x, 4 plus 3x upon 4 minus 3x. Why, sir? Because if you take LCM, 3 and 3 will cancel. Both the denominators will be cancelled to each other. So this is my final answer. Okay, this is my answer, bacha. So see, not all the questions will be difficult. Okay, simple, very simple problem. Okay, chali. Hope this is visible. Yes. Okay, sir. Now this, what did I say if you have a quadratic in the denominator? Can you recall it, or you forgot? I said just 10 minutes back, right? What are we going to do if we have a quadratic term in the denominator? Sir, make the perfect square. Make the perfect square. Why perfect square, sir? Because the formulas is there for perfect square, sir. X square plus a square minus x square. All the formulas are there for that situation. So let's see this, what we can do. So I'll just take this part. I'll not take the integration. I'll just take the term. Okay, I have the space. So I'll write it as x square plus 8x plus 20. I'm transforming this denominator, okay? Will become what? X square plus, whenever you are making this perfect square, no, write 2 times of x as it is. Why, sir? Because see, formula is 2ab. You know x is a, so 2a is to okay. Now what is to be written here to get 8x? 4, sir. So 2ab, this way you get 4, your b term very easily. So my b term is what, bacha? My b term is plus 4 square. Yes or no? B square. Extra I have added, so subtract that, minus 4 square. And whatever is there, you write that also. Please check. I have added a 4 square, so that's why I have taken it out, and then 20 was given in the question only, so I wrote it like this. I'll club this part together, bacha. X plus 4 the whole square. And how much is this? 16 minus 16 plus 20. How much is this? X plus 4 the whole square plus 4. Okay, now please check. So my integration is transformed into integration of 1 upon x plus 4 the whole square plus 4. Okay, dx. So this can be written as 1 by x by 4 the whole square plus 2 square dx. Which form is this? Sir, a square plus x square, tan inverse of x. So I'll write it as 1 by a. What is my a in this case? 2. 1 by, please have a look, a. So a is 2. From here, a is 2. Okay. Tan inverse of x by a. What is x, bacha? X plus 4 by 2 plus c so will come. This is my final integral. Please have a look. Any option like this? 1 by 4, 1 by 2 is there. So 1 by 2, these two, plus 4 we need. So option B. Correct, na? Plus x plus 4 is there only in this term. Okay? Yes, x plus 4 is only in this particular option. So option B is correct answer. Please have a look. First, what we did, if we have a quadratic term ax square plus bx plus c, we make what? Perfect square. We got it like this. We use in the integration, use the formula of the particular function for tan inverse, got the result like this. Simple, very, very simple. Looks complicated, but actually simple because of the single, way of thinking. Not that much there. Okay. Now this is that case. Which case, sir? Please see this. Yes. Whenever you have a linear and this given in the form of either quadratic or square root of quadratic, what we do? A plus d of dx by denominator. Okay. So I will use this rule only. What I'm going to do? Write my numerator as, instead of px, I'll write px plus b equals to a, another variable I'll assume a times of differentiation of the denominator plus b. You'll see this. Same thing I'm going to do first. Let me show you. Okay, I'll write this part first. So what it was given? Whatever is numerator, write that equal to a variable a multiplied with differentiation of the denominator, not the root, only the values, okay? Like this, and plus a variable b, okay? Next step is do the differentiation. I get what? A times of 2 minus 2x plus b. How come, sir? You know the differentiation, bacha. 3 is 0, 2x is 2, minus x square is simply 2x. Please compare the coefficients for x and the constant term. I get what? For x I get simply minus 2ax. For constant I get 2a plus b. I have done nothing different. Please have a look. 2 times of a minus 2ax and 2 times of a is 2a and plus b is there. I have here as 7x plus 3. Yes or no? Yes, right? Very, very simple. How? What we're going to do now? We're going to compare the coefficients. We're going to compare the coefficients. So please check here. I'll compare 7x with minus 2ax. You must have got the answer also. 7x equals to minus 2ax. What is my a value? Sir, minus 7 by 2. Why, sir? X and x will cancel. 2 will go here. Negative is there, so minus 7 by 2. Yes, minus 7 by 2. Now put this in 2a plus b. Sir, 2a plus b is equal to, not visible, sir. 2a plus b is equal to what, bacha? Have a look. Have a look. No problem, no problem, no hurry. 2a plus b is equal to what, bacha? 3. 2a plus b is a constant term, na? Equal to 3. So I'll write here as 3. I know the a value. Substitute. Please check. 2 cancels. Minus 7 plus b is 3. It means what? B is 3 plus 7. So b is 10, sir. B is 10, sir. So we have found a value as minus 7 by 2 and b value as 10. Okay. Now next step. So next step is what? If I take this as my integration I, okay, then I can rewrite this integration I as, please have a look, I as, my numerator will be this thing. What is the numerator? Please check. This I can write it as this part, okay, over here. Please have a look. I'll write this for my numerator now. Instead of writing 7x plus 3, I'll write this with the help of a and b. So it will become what? Please check for the first term. I'm replacing 7x plus 3 as a times of 2 minus 2x. What is my a? Minus 7 by 2 times of 2 minus 2x. Okay? Plus b. What is b? 10. So I'll write here plus 10 divided by the same thing. What was it? 3 plus 2x minus x square. X square. This is okay. Now please have a look. Okay. What I'm going to do, I'm going to separate this with the help of plus sign. I'll write this integrand as I as minus 7 by 2. This is integration, right? So minus 7 by 2 is a constant. I've taken it out. Okay. 2 minus 2x. This dx was there, bacha. Sorry, I forgot to write. Okay. 3 plus 2x minus x square is here. Okay. Yes. And what is this? Please have a look. Plus 10 times of integration of what? I am separating the integration. 1 upon this. Simple. Now please assume this integrations in two parts. This as my integration I1 and this is my integration I2. Okay. So integration I1. So I am basically writing this as I, this whole integration I as I1 plus I2. I can do that, na? I can separate the integration. We have learned the property of integrations. I can apply the integration in the plus sign individually or the minus sign also individually. Please check. Minus 7 by 2 is there for I1 and 10 is there for I2. Okay. Now for I1 if I do. If you take this as t, please have a look. If you take this as t bacha, what will happen? What will happen, sir? This will be simply, so if I do only for I1 now, only for I1 now, if I am doing only for I1 now, I1 will be written like this, minus 7 by 2 will be common, of course, and this will be what? Simply, if I am taking this as, you will get it as t dt by root t. You will see how. I will show you. So what I am trying to say here is take t equals to this thing, 3 plus 2x minus x square. We just saw this differentiation, no? We will get what? dt by dx equals to what? 2 minus 2x. Yes or no? 2 minus simply 2x. Okay. So I can write dt as 2 minus 2x times of dx. Yes, there is no dx, I have to write here dx. So I can replace this dx times of 2 minus 2x as dt and this root t will be as it is. So what is this? Simply integration of minus 7 by 2 is outside, t to the power what? Minus 1 by 2 dt. What's the integration of this bacha? Tell me. Simple, sir. Minus 7 by 2, okay, you add this 1. So t power minus 1 by 2 plus 1 and minus 1 by 2 plus 1. C will come as the constant of integration. Okay, chaliye. Let's see this. Okay, how much I'm getting? Please check. Minus 7 by 2. Okay, this is going to be t 1 by 2. T 1 by 2. Please have a look. T 1 by 2. Here 1 by 2 is there, bacha. This is 1 by 2, minus 1 by 2. So if you add minus 1 by 2 to 1, you will get what? 1 by 2. And what is the same thing will come here? 1 by 2. This will go up. This 2 will go up. What are you going to get? You will get it as minus 7 into 2 upon 2. And this will become simply what? Root t plus c. Please check. T power 1 by 2 is what? Root t. So root t plus c. So t and t, 2 and 2 is cancelled. What is my a1? What is my I1 now? My I1 is simplified as minus 7 root t plus c. What is root t here? Please check. My root t is minus 7 root of 3 plus 2x minus x square plus c. Please check. T is what? T is what? 3 plus 2x minus x square. So instead of writing this root t, I wrote it as this formula. This is my I1. Integrand number 1 is identified. Now let's check any option can be found using this. So plus sign is coming. Plus sign is coming. So plus sign of, so two options are there, either A or C. We'll see. Okay, two options are there, either A or C. Now if you are thinking like this, I'll show you. Plus 10 is there. If you see, what is the coefficient of the I2? Coefficient of I2, check here, 10. What is the coefficient? 10. If you want, you can write this directly as the option number 10. Okay, but anyway, we don't want to take a chance. We'll solve it. We'll solve it because sometime what happens? No, you'll get 10 by 2. I'll get cancelled. Okay, you'll get 1 by 2 also. Will get cancelled. But if you remember, I'll give you a trick. For sine inverse, there is no x by a or 1 by a. See this formula. For sine inverse, there is no 1 by a over here. Is there? There is no 1 by a. So it means whatever is the coefficient that we have over here, here for sine inverse, it has to be the constant multiplied to integration. Because if it is transforming into sine inverse, You cannot have anything coming for below 10. You cannot have that. So if you want, take this answer directly as C, sir. Answer is directly C, sir. Okay, I'll solve it, don't worry. But if you want, you can take this answer directly over here as what you call your C option. I'll show you what is my I2. I2 is 10 times of the same thing. Now I'll go for I2, please check. So I2 will be what, bacha? 10 times of 1 upon root of 3 plus 2x minus x square dx. Okay, please check. 10 times of, I have to make what? Perfect square, sir. Why? To get use of the any of the formula. This will become what? 3 plus, I'll take a minus sign common here. I'll take a minus sign common here to make x square positive. It will become what? Minus 2x plus x square. Okay, dx. Now check this. 10 times of 1 upon 3 minus, I have x square, I have minus 2x also. So what is missing? Only 1 is missing. So add plus 1 square and subtract also minus 1 square. Correct, right? Please check. xa square minus 2ab, b is what? 1. So 1 square I have added, subtracted also the same thing. Whatever I am adding, I have to subtract that also. This is what? Dx. 10 times of dx upon, please check here, I get 3 minus, I'll club this together, I'll get x minus 1 the whole square, and this minus will become what? Plus. So plus 1. Now look at over here. So my I2 will be nothing but 10 times of dx upon, check here please, what are you going to get? You'll get at 3 plus 1, how much is that? 4 minus x minus 1 the whole square, how much is that? 10 times of dx upon 2 square minus x minus 1 the whole square in the root. A square minus x square in the root, sine inverse formula. What is the answer? 10 times of sine inverse of x by a. What is x in this case? X minus 1. What is a? 2. Any option like this, please check. 10 times of sine inverse of x minus a. X minus 1 by 2. Option number C. So I said that if you don't want, look at the coefficient, get your answer, because you cannot have the other two, right? There was a minus sign, so this and this was not possible only. Sorry, not this. This and these two are not possible because of minus 7, minus 7. I want a plus 7. So only A and C is possibility. In the A, I have 5 as the coefficient. I can't have 5 because I2 is 10, and in the sine inverse, I don't have 1 by A. Okay, so it has to be 10 only. It has to be 10 only. Any problem? Any problem? Have a look from the beginning. Okay, have a look. Okay, now this question. From here you look. I hope this is visible. Okay, here. All right, I'm moving on to the question number 6. Okay, chaliye karte hain. Evaluate this condition. Evaluate this integral 1 upon 1 minus e power 2x in the root. How will you solve it, bachcha? Okay, it means, sir, look at here. It means that it will come somehow as x square minus a square in the root, sir. Correct, na? Right? It come like this. Because you see here, log of x plus log of x square minus a square is the options. Okay, so this formula will be applied. Okay, we'll see, no problem. We'll see now. So let's see here. Let's have a look. So if I look at this, what I'm going to do is I'll write this as integration I as integral of. Let me take something common here. I'll take what? E power 2x common. In the root only I'll take. If I take e power 2x common, what I'm going to get? I'm going to get this as e power minus 2x minus 1 dx. Okay. Sir, why, sir? You'll see. Just wait. Okay. Now, e power minus 2x minus 1, that is okay. I've taken this common. E power 2x I've taken common. Sir, why e power minus 2x? Because if we multiply this, what will happen? E power 2x plus minus of 2x. How much is this? E power 0. How much is this? 1. So 1 was there, right? So I had to, if you take e power 2x common from 1, you'll get it as e power minus 2x. If you are having difficulty there also, Not able to understand this part also? Write like this. If you take e power 2x common, you'll get it as 1 upon e power 2x. So that if you get cancel, both of them will cancel. So if you take it common, you'll get what? E power 2x. 1 upon e power 2x will become what? Tell me. E power minus 2x only, no? If this goes up, it will become what? E power minus 2x. That's what I've written here. That's what is written there. One second. Chaliye. Let's move on. Let us move on, sir. Okay. Now take this e power 2x outside. Why, sir? Square is there, no? E power 2x is there. If I take outside, what will happen? I'll get it as e power x, sir. Now see this. This is actually e power x the whole square, and this is e power minus x the whole square, and this is what? Minus 1. Okay? Okay? Not whole square means power to power rule is there. What will this become? This will become, I'll take this upside, e power minus x. Check this out. What will this be, bacha? In the root, e power minus x square, okay, minus 1 square. Okay. Now I'm going to take e power minus x as t. Take e power minus x as t. Now take the transformation. dt by dx will be what, bacha? It will be e power minus x into minus 1. So my dt will be what, bacha? Minus e power minus x dx. So I can write this simply. This part as minus dt, because this minus sign is there. So there's no minus sign over here. I can write this as simply minus dt. Okay. Now check this question. So my I will become, this is there, I'll write it once more just for reference. I have e power minus x square minus 1 square in the root. Okay. Now please have a look. It will become what? Minus dt upon what? Root of t square minus 1. I said this. In the root, if you have only a square minus x square, that will make what? Sine inverse. Any other case, x square minus x square will what? Will be what? Please check. Minus sign will be outside. You'll have log. You'll have log. Log of what? First x will come. So t will come. Then what? Plus sign will be coming. And whatever is there in the root, same thing right here. I'll repeat. If it was 1 minus t square, you'll use sine inverse. But since it is t square minus 1, okay, then what are you going to use? Log. Okay. What is it? X plus this form. Please check. What is the answer? Minus log. What was t, bacha? E power minus x plus e power minus 2x plus, not plus, minus 1. Minus sign is there, no? So I'll use same one. Minus 1. This is my answer. Final answer. Simple enough. Okay. Have a check an option. Plus sign should be there. So option number B. Why C is not there? Because this has to be plus. Okay. This cannot be minus. So option number B is correct answer. Please check. Plus. Okay. Plus has to be there. Minus sign is there because of the differentiation of dt. Please have a look. This because of this reason. This is the minus sign. Okay. Okay. From here you can check this minus sign. Okay. And that minus sign is existing over here. And this is in the formula only. Plus. Okay. Plus is there. This is okay. This is all right, sir. Any problem so far, sir? No. I hope this was visible. Yes. Have a look, please. Yes. Option number B is correct. Everything is visible, sir. Yes. Yes. Okay. What about this? What about this? Visible, sir? Yes. Okay. Chaliye. Question number 7. Question number 7. All right. Root is there in the numerator. Root is there in the numerator. Okay. Please see what we can do about this. So we will have to use which formula? Please have a look. Only one case I've given like this. Only one case I've given like this, which was this one. Okay. Did I miss the root? Yes, I think I missed the root. Okay. Okay. All right. So if you see here, yes, I have missed the root. In the formula, no, the root have been missed, please make the change. Okay, please make, I'll make the change. Let me just solve the question, then I'll make the change, no problem. Okay, just I missed the root. Okay, chaliye. So 7x minus 10 minus x square is there. Sir, whenever we see this term, what we do for one thing, perfect square, we'll do the perfect square. So sir, how we make perfect square? There is a minus x square term. Take minus common. Sir, how will take minus common? There is a square root. We can take inside the root also, no? So we'll deal with only this part right now. So I'll take what? Minus 7x plus 10 and plus x square. Please check now. This is in the root, okay? What will this be, bacha? Minus x square is as it is. I said what? Write 2x first plus 2x you write. Okay, this is a minus sign, no? So write here minus. Right there a minus 2x. Okay, I need to have minus 7x, so I'll write what? 7 by 2. Please check. Now if multiply, 2 and 2 will get cancelled. 7x is there. Okay, sir, minus 7x. I need b as 7 by 2, so I'll add this 7 by 2 square. How much is that going to be? Tell me. 49 by 4. If I'm adding something, I have to subtract that also. So minus 49 by 4, and whatever is the remaining plus 10. So write that also. Close the bracket. Close the bracket. Now please check. Please have a look. So if you look at this, what I'm getting it as integration of minus x minus, okay, x minus 7 by 2 the whole square, and how much is this? Plus 40. 4 times 10 is plus 40. So minus 9 by 4. Now open the bracket in the root only. Next step. Open the bracket. If you open the bracket, it will become what? 9 by 4 will be positive, bacha. Please check. Minus of minus will become what? This is 9, okay? This is 9. How 9, sir? Minus 49 plus 40. So minus 49 plus 40 will be minus 9 only. So minus 9 by 4 will become positive because of this minus sign. And then this will become negative. Okay? How much is this? X minus 7 by 2. This whole thing is in the root with dx. Now please check. Okay? 9 by 4 minus x minus 7 by 2 the whole square. What is the condition? So if you have, what is this? Write this form. Root of 3 by 2 the whole square, okay, minus, this is a whole square, okay, x minus 7 by 2 the whole square dx. Okay, please have a look. Same thing is written here. The condition is, first thing is x by 2, same thing you will write in the root only. 3 by 2 minus x minus 7 by 2 the whole square, okay, and then what? Plus a square by 2. What is a square? So 9 by 4 by 2, okay, times what? Times what? Sine inverse of x by a. Sine inverse of x by a. What is x, bacha? X is x minus 7 by 2 by a. A is what? 3 by 2. Have a look. Have a look. Let me simplify this. This is my integration I. Final answer. And plus c will come, obviously. Plus c will come. Have a look. This is going to be x by 2. This will remain as it is. 3 by 2, okay, the whole square obviously. Please check the option. Yes, okay. 3 by 2 the whole square obviously. Okay, this is not x, right? X is x minus, forgive me, I made a mistake. This is not x, right? X is x, x is what? 7 minus, this is x, x minus 7 by 2 is actually x, right? So it's going to be 2x minus 7. Let me rewrite this statement, the last line. Just give me 1 second. This will become what? 2x minus 7 by 4, if you check, right? 2x minus 7 for the numerator. 2 will come down, with 2 will become 4. Now in the root, what is this? 3 by 2 the whole square minus x minus 7 by 2 the whole square. Please check. This thing is there, no? 3 by 2, this is the same thing, right? So I can rewrite this as the original expression. Whatever I got after simplification, this part, I can rewrite it as the original expression. What is that original expression? 7x minus 10 minus x square. So 7x minus 10 minus x square. Why, sir? After using the perfect square, I got this form, right? After using perfect square, I got this form. So I can rewrite this as the same thing. Okay, chaliye. What is this going to be? Plus 9 by 8, plus 9 by 8. How much is this? Sine inverse of, how much is this? 2x minus 7. 2x minus 7 upon 2 is there, and 3 by 2 is there. 2 and 2 cancels. 2 and 2 cancels. What I get? My final answer is 2x minus 7 upon 4 times 7x minus 10x minus 10 minus x square. Sorry, this will be what? Plus 9 by 8 sine inverse. How much is this? 2x minus 7 upon 3 plus c. Please check for any option like this. This is the final answer. 2x minus 7 times this whole thing. 2x minus 7 by 4. There is a minus sign here, so I cannot take minus. There is a minus sign over here, so I cannot take this option also. Option number A. Option number A. Have a look. 2x minus 7 by 4. 2x minus 7 by 4. 7x minus 10 minus x square. Correct? 9 by 8 sine inverse of 2x minus 7 by 3. Okay. Now I wanted to make this change. I forgot there while typing. I think I missed it. Forgive me for that. Horrible mistake. This is going to be what, bacha? A root. Okay. So let me just erase this part. Okay. This is just a root. Okay. Same thing. Same formula we use. X by 2 a square minus x square. A square by 2 sine inverse of x by a. Same formula we use right now, right? This is the formula that we use right now. Okay, we have used this formula. So there is a root over here. Just mention this. Root of a square minus x square. Okay, chaliye. Okay, sir. Question number 7 we were solving. I will show you again everything. So first thing was making the perfect square. I hope this is visible. Second thing was, after making perfect square, we had to apply the formula. Big formula. What was the formula? X by 2, whatever is x. So this whole thing is x. X by 2. Whatever is in the root, same thing you repeat over here. Plus, what is it? This is going to be my a square by 2. Okay. A square by 2. And this will become what? Same thing as sine inverse of x by a. Sine inverse of x by a. We got simplified this as my final answer. My final answer. Okay, big answer, yes. Moving on, hope this is visible. Moving on. Okay, resolve into partial fractions. Very, very simple. This is, I've taken only for introduction, okay, just wanted to show you how this will work. So what we do, we try to, put this given fraction into two different forms. Means, if you remember, from here minus 1 we can separate it, okay. But how will we separate it? We don't know the coefficients. So I will write this as a upon one of this thing, so t plus 4 and what? Plus b upon other one, t plus 5. And we solve for a and b. Whatever a and b values are, we solve for that. Okay. So we'll try to resolve into the partial fractions like this. Okay. Let's check. Let's check what will be the case. If I do that, what I'm going to get? Please check. I'll get it as 2t minus 1, t plus 4. Okay, more than a concept, no, this is a tool actually. More than a concept of partial fraction, it is actually a tool which is used to solve multiple questions. Okay, t plus 4 times of t plus 5 is given by what, bacha? Please check. I take this as, so a times of what? I'll take what? T plus 5 on that side, and over here I want to take plus b times of t plus 4. I'm taking the LCM. What is the LCM? T plus 4 and t plus 5. T plus 4 and t plus 5. Have a look. T plus 4 and t plus 5. Yes? Yes. Now compare the coefficient of constant term. Compare the constant term and compare the coefficient of t. For that I have to simplify this. Please simplify this. Just for t, what I'm going to get? I'll get a from here. So a. And what I'm going to get from here? B. Yes. Same way. For constant term I get 5a plus 4b. Okay. The denominator over here will remain same, and this also will remain same, 2t minus 1. This also will remain same. I'll compare only the equations. Please check. So I get t times of a plus b is 2t, right? And we also get 5a plus 4b is minus 1. Am I right? T times of a plus b is 2t and 5a plus 4b is minus 1. I am comparing the numerator part. Please compare the numerator part. Have a check. Have a check. Okay, correct. This is not 13. This is b. Okay. Okay. So I'll get what? A plus b equals to what? 2. So what is a equals to? 2 minus b. Put it here. 5 times of 2 minus b plus 4b equals to minus 1. So 10 minus 5b plus 4b equals to minus 1. Okay. So 10 minus b equals to minus 1. So what is this? Bring it here and bring this here. I get 10 plus 1 equals to b. So I get b equals to 11. b equals to 11. Now put it here. A equals to 2 minus 11. How much is that? A equals to minus 9. A equals to minus 9. Okay, correct. Now I got this. What was the function, if you remember? It was given by 2t minus 1 upon t plus 5 and t plus 4. Okay, t plus 4 equals to a upon, what was a? What did I get my a as? My a value is minus 9. So minus 9 upon, what is my a? T upon 4. So t plus 4 and plus, what is b? 11 upon t plus 5. Any option like this? Please check. Okay. Yeah. Okay. Okay. Chaliye. I can have this also as my option. B also can be true. Okay. Why, sir? If I interchange a and b, no. If I interchange the variables a and b, so I write b here and a there, I'll get the same result. This will be reversed. Okay. This will be reversed. Okay. So for this condition, I got an answer. Let's look at this. Okay. Hope this is visible. My answer. Chaliye. Now this condition, I think last problem of the day. Yes. What is saying? If dx upon, okay, integration is given by this condition, a tan inverse of x by 2 plus b tan inverse of x plus c, then find a plus b value. Find a plus b value. Okay, we'll see. So again we have to use what? We have to use a partial fraction over here. How will I use it? Please check. 1 upon x square plus 1 and x square plus 4 dx equals to integration of, or I will forget about the integration right now. I'll rewrite this thing. Only the fraction part. Equals to what? A upon x square plus 1 plus b upon x square plus 4. Simple. Okay. Now please check what is my a going to be. Compare this. So a times of x square plus 4, okay, plus b times of x square plus 1 upon x square plus 1 and x square plus 4. Am I right? Compare this over here and x square plus 4. Now if you check here, if you compare only for x square coefficients, what's the coefficient of x square? So I get here a times of, I'm writing only RHS part, okay. So a plus b times of x square plus, again what? 4a plus b. 4a plus b. Please have a look. So what I'm doing here is, x square I'm taking common, so what I've left here? A plus b, so a plus b, and a constant term 4a plus b. 4a plus b. Now what is the coefficient of x square here? Please check. 0 x square plus 1. What is the coefficient? 0 is there. So I'll write a plus b as 0. I'll write a plus b as 0. Why, sir? Why, sir? Because Coefficient of x square is how much? Please check in this term. There is no x square, means it has to be 0, right? It has to be 0. So a plus b is 0 means what? It means a equals to minus b. Okay, let's move on. 4a plus b equals to 1. Compare the constant term. 4a plus b equals to 1. So have a look. 4a plus b equals to 1. So what it means? It means 4 times of minus b plus b equals to 1. It means what? Minus 3b plus b. 3b plus b equals to 1. Please check. Minus 4b plus b, how much is that? Minus 3b. Okay, so what is my b equals to? Minus 1 by 3. Minus 1 by 3, sir. Yes. What is my a equal to then in that case? From here I can write a equals to simply 1 by 3. Okay. Now write the integration. So I'll write integration of 1 upon x square plus 1, x square plus 4. 1 upon x square plus 1 times x square plus 4 can be written as the partial fractions. What is it? 1 by 3 integration of 1 upon x square plus 1. Have a look. X square plus 1, and for b minus sine 1 by 3 integration of 1 upon x square plus 4, right? So if I both side I have to write dx, Now if you integrate this, what I'm going to get? 1 by 3 a square plus x square, simply tan inverse of x. What about here? Minus 1 by 3 tan inverse of, how much is this? Tan inverse of what? X by a. So this is x square plus 2 square, right? So tan inverse of x by 2. Tan inverse of x by 2, and plus c will come. Okay, plus c will come. You have to write here also 1 by 2, no? Because 1 by a have to take. Please check here. 4 is there, right? My 4 is what? I can write 4 as 2 square. Okay, so that's why x by 2, and over here also 1 by 2. So please simplify this. 1 by 3 tan inverse of x minus 1 by 6 tan inverse of x by 2 plus c. Compare it, please. Compare it. A tan inverse of x by 2. What is my a? My a is minus 1 by 6, and then the one b tan inverse of x. So what is my b? 1 by 3. My b is 1 by 3. Okay, and c is as it is. Please check. This is a constant, so as it is. Okay. Now one thing, sir, you got different value for a, different value for b here. How is this possible, sir? Understand this. This a and b is only the partial fraction constants. I can take this as alpha and beta also. Doesn't matter. I can take any arbitrary variable for this, but this is the variable given in the question. There are two different variables. This a and b are different variables, and this a and b are different variables. Okay, this is for the partial fractions. So I hope this is clear. Now what are they asking? They are asking us a plus b. They are asking us a plus b. My final answer over here. So minus 1 by 6 plus 1 by 3. How much is this, bacha? Tell me. Simply 1 by 6. But let's take LCM. Minus 1 plus 2. So 1 by 6. What is my answer? 1 by 6. Option number D. Option number D. Any problem? Okay, I hope there is no problem. But if there is, have a look. If there is, okay, then you will let me know, right? You will let me know. So I have tried to solve questions on some particular functions. I have taken the varieties, you can see there. It was extensive. Even for just 9 questions, we took a lot of time because the question is time consuming. We also took the some definition and some understanding of partial fractions. Again, they'll solve in the more questions on this category in the coming sessions. Okay, but for today's session, this is it. I've taken 9 questions. Very good questions I've taken. I personally liked them. If I've made any mistakes, comment below. Allow me to change it. But I've tried not to make any mistake from my end. But if there is, I'm also a human being. I can make a mistake. If there is, let me know. I'll try to correct that. Okay. Any other feedback is there in the comment section? Please feel free to let me know. Okay. Please feel free to say anything that you feel like, that anything that we can make and work to get our sessions better and better, and help you in the best possible way. Okay, so this is it, bacha, for the session number 3 for integration. Okay, I hope you are working really hard. Okay, you need to. Integration, right? Very difficult at times. So you have to work really hard to create the chain between the calculus first part limits to differentiability to the integration. So all of this has to be remembered at one time. So if you are solving a good question in KCET examination for, let's say, integration, all the concept you should know to solve one question. That's how calculus is related. It's not different chapter, it's one complete unit. It's like a family. You have to know all the things. Okay, so with that, on this note, I'd like to end the session. Please keep working hard, keep smiling all the time. We'll see you, not like a crazy person. Keep the positivity around you, obviously, and I'll see you in the next session. For now, take care. Bye bye.